let's go to example number 2 and try the exact same thing out. We want to solve again using a calculator. And just running through real quick, looks like we have everything in the correct order, x, y, z's, with all the constants on that on the right side. So my coefficients on my x's are 1, -2, and 2. On my y's are 2, -3, and 4. My z's are 1, -1, and 2. And equaling out is -2, 1, and -4. Alright, so let's pause this and plug this into our calculators and let's compare answers again. Alright, and when I got this all plugged into my calculator, this is what I got coming out. Reading across that first row, it's basically saying x minus z is equal to 4. The second row is saying y plus z is equal to -3. You see how both of them have z's in common? That's what we're going to throw to both the other side in general. Okay, so to really write this answer out, we're going to say, all right, x is going to be, like 4 plus z, just moving the z's over. Y is going to be then, let's say, -3 minus z, and then in this case, since they're both whatever variable you're throwing here on the right, and if they share one, make sure that's the same one that's thrown to the right. And then the z is the one that can be all real numbers. Okay, so or if we put this into a coordinate form, we'd write that as 4 plus z for my x, -3 minus z for my y, and then the z itself can be any real number. And I think sometimes if you look at your answer in the book, they could replace that. Like in this case, the variable is z, the one that's shared, sometimes they replace with a t, but it doesn't really mean anything. It's just know that whatever the one that's shared, that's most likely going to be the ones that's going to be all real numbers. Okay. All right. So let's go on to example 3. Just getting some more practice here with interpreting what our calculators tell us. Let's look here. Instead of x, y, z's, looks like we have x1s, x2s, and x3s, but everything's situated correctly how we want it. So x1s are going to be 1 and 1s. x2s will be 2 and 1s. x3s are 4 and 2s. And what we're equaling is 2 and 1. All right, again, let's throw this into our calculator, do a little RREF, and see what comes out. This was just a little bit different, because if you notice it's like, look at the dimensions on this one. There's only 2 rows, but look how many columns. There's 4 columns. So that was kind of a little bit different. Most likely, with that being that weird, we're probably going to have a unique solution. Look what we've got here. In that first row, it's just telling us that, remember, this is x1, x2, and x3. So it's saying x1 is equal to 0, and then it's saying x2 plus x2 plus 2x3, got to make sure I get that coefficient in there, equals 1. Okay. Again, really on the second one right here, we know what x1 is. It's for sure 0. On the second kind of equation we have right here, we can choose to solve for either one or the other one. I just tend to throw the later variable in the back, honestly. It's kind of what my inclination is, but it doesn't really matter. So x1 is going to be 0. x2 is going to be 1 minus 2x3, and the one you choose to throw over, that's the one that's going to be all real numbers. So just like that. Or in coordinate form, it's going to be 0, 1 minus 2x3, and then x3 is all real numbers. Just like that. Okay, well hopefully we kind of got that a little squared away. Let's go to example 4, which is number 34 in the book. So if you'll do me a favor and just pause this video, pull out your book again, make sure you've got it around, and read through it real quick, and let's come back together and figure this out together. Alright, and as I was reading through this example, I kind of just wrote down the chart again so we can really talk this out, and I can point at things and not have to be pointing at the book and you have no idea what I'm pointing at. So, reading through this, a dietitian is trying to build a plan, a meal plan. And this meal plan has to have so much vitamin A, vitamin C, and calcium in it. Okay? And we have 3 types of foods that we can potentially give a person. Okay. We know for a fact that a meal has to have a total of 8,800 units of vitamin A. So that's what I did here. It's this, when you're reading this, basically this chart, everything here in row 1, it's all about, okay, this VA for vitamin A is that food 1 has 400 units of it. Food 2 has 1,200 units. and food 3 has 800 units of vitamin A in it. Okay, so I need a total of 8,800 units. So what I don't know is how much of each should I get? Should I get like, 3 servings of food 1 and only 1 serving of food 2? Okay, or should I get, all like 5 servings of food 2 and maybe 1 serving or 2 servings of food 3? Because I know I have to have a total of 8,800. I just don't know what combination of each. And the same thing goes with the row 2 and the row 3. The however much of vitamin C, all I know is I need a grand total for my full meal. My full meal is made up of these individual foods, 1, 2, and 3. Like food 1 could be carrots, food 2 could be hamburger, and food 3 could be, I don't know, like fruit or something. All I know is I need to for sure in my meal have 3,380 units of vitamin C and then of calcium 1,020. So if we go to the very, very last sentence, what it's asking us is determine the amount of each food. Not the amount of vitamin A, vitamin C, and calcium, it's the amount of each food. Well, there's food 1, food 2, and food 3. So there are our variables right there. Let's let food 1 be X, food 2 be Y, and food 3 be Z. So it says how much of each food. Okay? And when we want to go and form our systems of equations, 3 variables, 3 equations. We're just going to build it off basically off these rows right here in front of us. So one row is going to be talking all about vitamin A because we know the amount of vitamin A in each food, and we know the grand total amount of vitamin A that we have to have, so therefore we have a full equation. Because if I'm getting 400 units per food 1, per mean multiply, and 1,200 units in food 2, and 800 units in food 3, that I need to figure out is what combination of these 3 will add up to 8,800. Same thing with vitamin C. 110 from food 1, 570 from food 2, and 340 units from food 3. I just need some combination of all 3 of those to eventually add up to 3,380. And last but not least, finishing out with calcium, just going to get some combination of foods 1, 2, and 3 that'll add up to 1,020. Okay, so when we go ahead and put this in a matrix form, it's pretty much all ready for us. We can just pretty much copy off the table, but we just want to double check again, make sure that those equations made sense, and we wanted to make sure that we were writing out the equations correctly, that we weren't summing up columns, we were actually just summing up the rows itself to form the equations. Okay, so if you guys want to go with me here, and we're going to put this in our calculator, and let's see what our calculator comes up with. Alright, and when I put this in my calculator, it looks like we're going to have one of those infinite solutions again, because we have one row that has nothing but a bunch of zeros in it, so we're just going to be based off row 1 and 2 to help get our answer. So it looks like we have x plus 0.5z is equal to 10, y plus 0.5z is equal to 4. And we don't know what z is, so obviously they both have z's in common, so we're going to chunk those both to the other side to help finish our answer. So we'll have x is equal to 10 minus 0.5z. We'll have y is equal to 4 minus 0.5z. And then right here we would normally say z can be all real numbers. Now, I say right here we would normally say that. Well, we have one special condition, because guess what we're doing here, guys? A word problem. And what does z really represent? Well, z represents the amount of food 3 that we're going to be eating. And is it realistic to say then that z can be anything? Because can you eat a negative amount of food? Not so much. So we really can't even say that z has to be positive. We can't just say, well, z is any number larger than 0, because we need to double check. Because we got to make sure that when I pick values of z, that it makes our x be positive and our y be positive. Okay, so let me erase some of these matrices. Let me show you how we're going to do this. So hopefully you guys have a lot of this copied down. If not, you can pause the video, go back and copy this stuff down, or go through at it again. You got all infinite time to do that. But let me show you how to do this. Okay, like I said, since x, y, and z, they're all representing positive things. the amount of food 1, the amount of food 2, and the amount of food 3, then what we're saying is what x equals, which is 10 minus 0.5z, it has to be greater than or equal to 0. It has to be positive. It's saying that the amount of food 1 could be either equal to 0 or it has to be greater than 0. So solving this out, it's saying 0.5z is greater than or equal to a negative 10. And divide both sides by, negative 5, 0.5. And remember, whenever in a inequality, whenever you divide by a negative number, remember we have to reverse that inequality sign. So now it's saying z has to be less than or equal to 20. Okay, so look how it's narrowed it down. Z no longer is all real numbers. Z is anything less than 20, which and still greater than, obviously, 0. But let's do the same thing with y. Because I know that what y equals, no matter what it equals, it still has to be greater than or equal to 0. So it doesn't make sense to eat negative amount of food 2. And again, solving just like we did before. So negative 0.5z is greater than or equal to negative 4. Dividing it out. And watching because I'm dividing again by negative. So it's saying z is less than or equal to, and then 4 divided by 1/2 is the same thing as 4 times 2, which is 8. Okay, so closely. We've got to blend these two to really give our full answer. This first one says z can be less than or equal to 20, and we're good to go. The second one says z is less than or equal to 8. You've got to pick the number that actually encompasses both of these. Well, less than 20 goes from 20 on down to 0. Less than 8 goes from 8 down to 0. So what gets doubled up is really the 8 less than 0, or is from 8 down to 0. So that's the one we're going to use. We have to use the one that gives us an answer that can solve both parts. Okay? So here we go. This is our full overall answer. This is how you're going to write it out. It is saying that x is still going to be 10 minus 0.5z. Y is 4 minus 0.5z. Instead of saying z is all real numbers, you're going to say z has to be something between 0 and 8. So the number of servings, or the number of units of food group 3, it has to be anywhere from 0 to 8. As long as it's from 0 to 8, then I'm going to get a positive number coming out for my food 2s and a positive number coming out for my food 1s, and then I can get any combination just like that. So there really is my overall answer. And again, that's exactly what's going to happen every single time. When you're in a word problem just like this, take your matrix and interpret it. If they have a variable in common, throw it over, just like we did with the z's. And normally you would stop right there, call your z's your all real numbers. That's it. But in a word problem, just take whatever's here on this back side and always set it greater than or equal to 0. Okay, always do that, just like I did in those two cases right there. And then pick the overlapping part. You know, from 20 on down to 0, 8 down to 0. So obviously it overlaps at 8 down to 0, and that helps you with your answer. Okay, let's go on to a new topic.